Hello, welcome to the video tutorial for covalent molecules. This is homework pages 3, 4, and 5. Okay, the first thing to know is that if you were absent today, you need to go onto Canvas and find the notes for day 2. There are not a lot of them, but it's going to be helpful. The most important thing we did in our notes today were we learned the prefixes for covalent, right? So mono is 1, di, tri, tetra, penta, hexa, hepta, octa, nona, deca. You have to memorize those 10. We'll use them often enough that it shouldn't be that hard. But as soon as you have these memorized, really the rest of covalent naming and formula writing becomes really, really easy. Okay. So what we're looking at now is formulas for covalent compounds. Formulas for covalent compounds are much, much, much easier than they were for ionic. So in class we also made this foldable, ionic compounds versus covalent compounds. So ionic compounds will transfer, there's that T in there, from something on that side of the periodic table, the metals, to the nonmetals, okay, transferring electrons, and metal has that T. So for formulas of ionic, we had our 4-step formulas, symbols, charges, crisscross, reduce, and erase. This was all Unit 3 stuff. Today what we're starting is covalent naming and formula writing. Covalents point this way, so it's only elements on this side of the periodic table, the nonmetals. We say sharing is caring. Okay, so they share electrons and covalent bonding. And what we do is we just translate the formulas. So the prefix in front becomes the number in back. Trifluorine is 3, so that just becomes F3. So instead of di in front of oxygen, it becomes the 2 after oxygen. There's no crisscrossing and there's no reducing. That's super, super easy as soon as you have these done. Okay? So let's look at a couple of these examples. The first thing I did was I highlighted the red, number 1 in red, because I want you to remember only 2 things get mono in high school. The second element and high schoolers that share water bottles, right? So mono is never given to the first element. Okay? So phosphorus with no prefix means 1. I wouldn't call this monophosphorus. So that just means if there's nothing there, that means I have 1 phosphorus. And mono on the second element means I have 1 here. So phosphorus mononitride means 1p bonded on to 1n. I just don't call it monophosphorus mononitride because only the second element gets mono. Number 9, di. So the letters in front become numbers behind. Di is 2, so that means 2 silicon. Hexabromide, hexa is 6. So that means instead of hexa in front of bromide, I'm going to put 6 behind Br. So 2 silicons and 6 bromines, Br6. Disilicon hexabromide. And one other thing you'll notice is that in the names, only the last word is changed to ide, only the second element. So this isn't iodide pentafluoride, it's just iodine pentafluoride. So just like it was in ionic, only the last 3 letters are changed to ide. Tricarbon, octahydride. Okay? Hydride is hydrogen, sharing electrons. Tri, like a triceratops, is 3 horns for a triceratops. Octa, like an octet or an octopus, is 8. So tricarbon means C3. Octahydride means H8. We're just translating. Super easy. Okay, hexa is 6. Deca, like a decade, is 10 years, 10. C6, H10. So the prefix in front, the letters in front of the element become numbers behind the element. I know, I like this better too. Maybe that's just me. Let's look at page 4. I think you should probably be able to finish these ones up. On page 4, now we're naming, okay? So we're doing the opposite of what we were just doing on the last page. So what we do is we write the first name with the prefix, but no ide. So in this case, there's 1 sulfur, so I just call it sulfur. The first element never gets mono. Okay, for this one, there's 1 carbon, so I just call it carbon. Example 3, there are 7 carbons, so I would use the prefix heptacarbon. Okay, 2 iodines, diiodine. Again, I didn't change that to ide. I only changed the second element to ide. Okay. So almost always the first element gets a prefix, unless it's mono. The second element always has to have a prefix. So that's when we would use mono. Okay, like in this case, monosilicide. And we do change the ending of that one to "ide." So, I5. The 5 means I have 5 iodines, so I need to use the prefix for that, which is penta, like a pentagon or pentatonics. There are 5 of them in that group. Okay, so I'm going to say penta iodine. Okay, and be careful. We're used to saying iodide from last unit, but if it's the first thing, I don't make it "ide." Okay, so penta iodine, and then I don't have a number after there, so that means 1. And the prefix for 1 is mono, so I would say monochloride. And I'm going to run out of room. That's okay. Monochloride. So this one becomes "ide," just the last 3 letters. 7 iodine. 7 is hepta. I almost said the wrong one. Hepta. Hepta iodine. Okay, and 4 bromines. I say 4 bromines by calling it tetra bromide. Okay, I have 3 sulfurs. I don't call that trisulfide because it's the first thing, so I'm just going to call it trisulfur. Okay, and then 5 chlorines is going to be penta again, chloride. Okay, let's come back up to this one. Now I'll do number 27. I've got 1 fluorine, but I do not call that monofluorine. Okay, just fluorine. Because remember, only the second element would ever say mono. So just fluorine. Not fluoride, just fluorine. And then this time, the iodine is the last element. So I'm going to call that pentaiodide. Oops, and that should be 1 letter. Shoot. I-O-D-I-D-E. Pentaiodide. So I want you to notice this. I5 at the back was pentaiodide. I5 at the front was pentaiodine. And there is a reason that fluorine is written first here and iodine is written second. It's based on electronegativity and lots of stuff that we don't have to worry about just yet. So just because iodine is second here, it becomes "ide." Because iodine is first here, it stays iodine. Okay? Otherwise, we're pretty good. This isn't too bad. What the concern is that people start to mix it up on page 5 with what we did last unit. Okay, so here now it's mixed naming and formula writing. So some of these compounds are ionic and some of them are covalent. Remember we said covalence, YMCA. If you're going to do that with your hands, you're pointing at the nonmetal side of the periodic table. Okay, so covalent compounds only have nonmetals in them. I'm going to try focusing this again. It's bugging me a little bit. There we go, a little bit better. And ionic compounds have to have a metal in them. What else you will notice as we're trying to write formulas is here, for covalent compounds, okay, on the foldable, for covalent compounds, a covalent name must have at least 1 prefix in it. So anytime you see a prefix like mono or tri, tetra, you know those ones are covalent. That's a dead giveaway, even without checking your periodic table, that both carbon and oxygen are nonmetals, and sulfur and oxygen are nonmetals. Okay. So I know that those ones are covalent. I'm going to look down here at these last 3. Fluorine penta, so that tells me that this one is covalent. I'm going to use the covalent rules for that. Chlorine pentachloride. Lead 3 sulfates. If I see a Roman numeral, I know that that one has to be ionic because ionics may have Roman numerals. Okay. And I don't see any prefixes. So I know that this one is going to be ionic. Silicon dioxide, I see a prefix. So I know this one's going to be covalent. Okay. So really, I recommend either coming up with symbols that you always write C and I next to them so that you remember mentally which set of formula and naming rules to use. If you're more visual, you want colors, then rock on. You can use highlighters on your test. Okay, so formula writing for covalent compounds. I'm going to look and say formula writing, I'm just translating. Prefix in front to number in back, no crisscrossing, no reducing. So fluorine with no prefix is an invisible mono, that just means S. Pentachloride, penta in front means a 5 behind, so Cl5. Done. We like those. Okay. Lead 3 sulfates. Yikesies. This is going to be a 4-step formula. It's ionic because lead is a metal, and because there is a Roman numeral, and because there are no prefixes. So symbols, charges, crisscross, reduce and erase. So let's do this. See if I can get those all on there. Lead is right. Nope. Pb, lead. So that's my symbol for lead. Pb. Sulfate is this one, not sulfur. Okay, it's not here. Be sulfate, SO4. SO4. Okay, so that's step 1, symbols. Step 2, charges. The name tells me lead, making a 3 charge. And sulfates, I'm told on this list, makes a negative 2 charge. Okay, step 3 is to crisscross. Because lead is making a 3 charge, I will need 3 sulfates. Because sulfate is making a 2 charge, I will need 2 leads. And then I can't reduce 2/3, and there's nothing to erase. So my final answer is Pb2, SO4, 3. Much more complicated than number 38. Covalence, I see a prefix and I say, oh, thank heavens, I can use the easy rules. Silicon dioxide. So, no prefix in front of silicon means invisible mono, so just Si. Di in front of oxide means a 2 behind, so O2. Done. We like the covalent ones so much more. Biggest issue we have is you can't mix these rules, okay? But otherwise, hopefully we're getting the hang of these. Thanks, y'all.